So my name is Isaac, and I'm here on behalf of ETC Core and Ethereum Classic Labs. We're headquartered in San Francisco, and we have developers working remotely like me around the world. And I wanted to trace today an idea and a theme of readability through our team and through the work that we're doing, both as a priority that we have as developers, as well as a characteristic that's derivative then of that priority, both in the practical and architectural aspects of the code that we're building. We think that it's valuable, and we think that it has diverse applications. So here are just 4 different connotations or potential definitions of what we might mean when we say readability. On the left, legibility. That was scrawled in my chicken scratch handwriting, and it might be kind of hard to read. That's one interpretation of what readability might mean. But because this context has a lot to do with computers, and because computers have fonts and abstract ways of dealing with words, we don't have to worry about legibility. We have Helvetica and Roboto to do that for us. The second example you can't see, and that's because it is either invisible or it doesn't exist at all. And because we're working in an open source context, that's not going to be the connotation that we're talking about. The work that we're doing, because it's open source, is inherently visible. And that's one of the things that makes it what it is, and it's one of the defining characteristics of the work and the technology that we're applying ourselves to. Well-written is another connotation of readability. And I want to say that things can be well-written, but not necessarily readable. So if you think, for example, about maybe a dense philosophy book or a dense science paper, those can indeed be well written. For example, like Gravity's Rainbow by Thomas Pynchon. I mean, people will reference it and talk about it, but nobody has actually read the whole thing because it's not readable, although it is well written. So that's not exactly what we're talking about either. The fourth example is ablesbar. And unless you speak German, that will also be unreadable to you. And that's because it's not in a language that you're familiar with. And that is going to be relevant to what we're talking about today. Being able to work with a language that you're comfortable with and that you can use is a facet of what readability is. And there are more interpretations and connotations of readability. Dave Cheney has given a couple of talks. He's one of the core Golang contributors, and he's also talked about simplicity, productivity for developers as characteristics of readability, and good naming, for example. But instead of trying to define readability, I think another approach that we can use is to ask, what does readability look like? So that we can know it when we see it, and we can then maybe know how to work in ways that we can build it. And I want to say that readability is about having the right level of abstraction in the right place. And because this is ETHDenver and not Art Basel, when we talk about levels of abstraction, we are going to be talking about words specifically. That's what words are. So don't be fooled by the progressively abstracting Mondrians. We are going to be talking about words. But the next nuance and really important essence of this understanding is the word right. What does it mean to have a right level of abstraction, and how do we know that it's in the right place? And I want to say that we'll know it's right based on the context and the purpose that is intended and is inherited as a part of the space that the document that we're talking about is living in. So we need intention and purpose to understand what readability is. Here's an example of something that is indeed readable. If we're trying to navigate and move around the world, this is something that can help us, but I think it's an example of something that probably is at a level that's typically too high of an abstraction. This will be useful if we have an airplane and a good stopwatch and we want to fly direct to Rome from wherever we are, we can do that. But if we're limited by we don't have a plane or we don't have enough gas or something happens on the way there, we won't be able to get there. So in this case, the job that this sign is doing is maybe not necessarily actually playing the role of wayfinding. I think it might be serving a slightly different purpose, even if that purpose is only letting us know how far away we are from cities, and to be something that you can take pictures next to. Oh, and we're missing a. There we go. All right. So here's another example of maybe what readability is or is not. This is taken out of a historical context in New York subway systems. The example on the left is something that is probably too detailed. There's too much information there, and maybe it's not structured in a way that's intuitive for the purposes of the user, at least not as well as it could be. And has been famously replaced by the example on the right, which is iconically readable, printed in Helvetica, and which has come to typify and actually symbolize the New York Metro today. But the New York train system is not even today without flaws as far as its signage. I found this on Twitter. And you can see the example on the left is at Penn Station, and we have what might be wayfaring instructions, but they're presented in a way that that perhaps reflects a shifted intention from actually helping you get where you need to go. And that's what I noticed in the comment on the right, where the commenter is saying that actually the purpose maybe of these signs has changed. Maybe they're not trying to help us actually get where you need to go, but they're serving maybe as an advertisement for the concept of travel, which is particularly ironic because your audience is going to be already in the train station. So why readability? I'm going to take Go-Ethereum as an example and talk a little bit about readability and writability in this context. So it's important that we have purpose for code. You do your job and do it well, and that's right. But in open source code, getting the job done may not be the entire picture. And maybe readability is a part of a bigger picture that also involves writing. And so one of the interesting and very self-apparent facts about readability is that things will be written more often than they will be. Things will be written far fewer times than they will be read. And this is true for books in a library. They'll be written once. They'll maybe be edited a couple of times, but and then recompiled, but they'll be written and then they'll be read. And so there's a disproportion there that as writers it's important to keep in mind. Keeping in mind, as graders it's easy to fall into a hole as a writer without working to remember that readership is one of the primary use cases for the words that you're managing. And in the context of open source code, not just is reading and writing a part of the case, but readership and writership is also a part of the case. And that's one of the things I want to point to here. And I want to point to the long tail distribution of writers that happens at Go-Ethereum. As you can see, this little bar graph reflects my hypothesis about a long-tail distribution of writers, which says that there are a handful of core writers who are writing the vast majority of the code over the vast majority of the period of time that this code has been in existence. There are a lot more contributors, but the majority of those contributors will be contributing small amounts. And compared to readership, again, this is the disproportion that we expect. We expect to see more readers, and we do see more readers than writers. In the case here, we can assume that stargazers are at least pure readers, even if they're only reading the directory structure of the repository and maybe the first few lines of the README. That still counts as reading. But one of the beautiful parts of what open source is and can do is the concept of forking and changing and contributing. And this is something that we hope actually for our projects for the most part. And so forkers we need to understand both as readers and as writers. And so what does readability do? Readability tells us a story that we can understand and use, and it enables and encourages writing. So at ETC Core and Ethereum Classic Labs, we're invested in Ethereum Classic. And Ethereum Classic is integrally and importantly related to Ethereum. We're a fork of Ethereum, or maybe it's the other way around. But we are invested in reading and writing the Ethereum protocol, working with the tools, and being a collaborative part of the ecosystem. Not just the ecosystem, but the actual protocol itself. The mantra for Ethereum Classic over the past year, and maybe even more than that, has been interoperability, and that's something that we're proud to say that we have today. And that's because it's a function of our relation to the ecosystem. And so as we're working with and towards the Ethereum protocol, we're inherently invested in characteristics like extensibility, like interoperability and configurability and accessibility for the code. And this isn't just good for us as core developers working on our classic implementation of the protocol, but it's good for our community, and it's good for the Ethereum main foundation community. And we're not alone. Ethereum Classic is far from alone in being a configuration alternative, or at least another opinion about what the Ethereum protocol can do. This is a very simple network crawler that I ran for a couple of hours and was able to find 239 distinct network IDs out there living on the dev P2P space. This is a bare minimum, right? This is network IDs. This doesn't reflect chain IDs. So keep in mind that even Ethereum Classic isn't included in this number. So Ethereum Classic Labs does a lot of things. We're an incubator and an accelerator for startups based in San Francisco. We're investors, and we're interested in exploring the space and lending strength and support and momentum to projects that we believe in and think have value. We're interested in building partnerships and collaborating because synergy and mutual trust and attitudes of openness are going to be beneficial for us and for the community. And last but not least, we're interested in development, and we're strongly invested in development, and that's what I can speak to today. And we have a good number of the core team here as well, so please come find us. We have a booth upstairs. We'd love to talk to you about some of the development things that we've been working on, as well as some of the more professional partnerships and things like that. We do have representatives who can speak to that as well. It's worth, so I've got these three different facets that I want to touch on from the development perspective. The first is protocol provider or specifications. This is what I'm most familiar with because this is what I'm working on. We also have what I want to say are two sides of the same coin, so to speak, which is contract development from the writing perspective and the compilation perspective, and then the consuming of those from the tooling and API perspective. All right, so I'm going to start by talking about the protocol specifications and the protocol provider that I work on primarily and that are the primary endorsement as far as protocol providers go from our company, which is Multi-Geth. Multi-Geth is a downstream fork of Ethereum, Go-Ethereum, and it serves ETC well, trustily, reliably, and with the multi in the name, it also serves a multitude of other chains, and that is by design. And these are chains that are not just research and development chains, but also production chains. One of the things about this client that's worth mentioning in the context of readability is that it's written in Go, which is famously readable. As I continue on with my example here, for those of you who may be initiated and familiar with some of the clients in the ecosystem, Parity may come to mind. Parity is written in Rust. And Go, compared to Rust, will have different answers probably when it comes to the question of readability, because Go is simple Go works to remove magic, and it tries to be accessible and productive. So I want to talk about one of the things that makes multi-Geth compared to its upstream ancestor, Ethereum, Go-Ethereum, and talk about some of the design trade-offs that we're looking at, and happy to talk to you about today. This is the configuration file, and I'm sorry if that's a little blurry. Ironically, I can't tell from here if it's just me, but I'm sure it's just the resolution of the picture. But you can see here that there's just a couple of lines, and those lines are fork configuration values for the Ethereum Go-Ethereum client. And a fork is usually a composite, almost always a composite of EIPs. EIPs are improvement protocol specifications. And the EIP space and the EIP process is something like the legislative body for the Ethereum platform and the Ethereum protocol. And that's interesting for me and for us today because it's written in English. And because of that, it's accessible if you don't write code. Or at least it's mostly English. You know, there's a lot of math and technical jargon, but if you can get past that, you don't need to be familiar with the nuances of any particular coding language to be able to work with it and to be able to make an impact on the protocol. And so a fork being a composite of these get bundled up and configured in the client like this. And so, as you can see here, they represent diverse sets of EIPs, and I've taken the Byzantium block as one. It represents 9 different EIPs. And these are EIPs that do different things. Sometimes they're related, and sometimes they're not. And navigating this for a reader for the Go-Ethereum codebase can be one of the challenges. And it is one of the notable architectural decisions for the client as well. So you can see here that we're configuring new opcodes, we're adding precompiled contracts, we're adjusting the difficulty bomb. And for somebody exploring this code base, if they use their IDE to do find usages, and where does this field value happen in the code? What does it actually do? They're going to find logic implementations that happen in the EVM, that happen in the interpreter, adding new opcodes, that modify how the revert is added and whether states can be modified or not. They're going to find difficulty being delayed. They're going to find block rewards being reduced. They're going to find actually the transaction receipts being managed differently. And this can be a hurdle. Well, why? These things seem unrelated. Why are they using the same parameters? So here's an example. This is the Ethereum Go-Ethereum house. And HIP here stands for Home Improvement Protocol. And as you can see, we've got the garbage disposal wired on the same wiring with the in-floor heating in the bathroom, and we've got the doorbell connected to the speakers, and it's all in the same circuit. And before you've got to imagine that a contractor comes into this house to like work on the doorbell, right? He thinks it's too loud, or he'd like to change the chime or something, and he comes in. And maybe an hour, a couple hours later, maybe a day later, maybe days later, he comes to you and he goes, you know, well, I've been testing the doorbell, and I can't figure it out, but the bathroom is getting warm. My doorbell tests seem to be passing, but the bathroom is getting warm. And whenever I do run the test, I hear this whirring noise coming out of the kitchen, and it sounds pretty angry. And so, but before we make too much of a joke of this, and I don't want to, I'm not trying to pick on the Ethereum developers, because this is not completely insane. They are good developers. They're very good developers, and I really admire them. And I've been working in parallel with them for years now. And they know exactly what they're doing, and they have very legitimate reasons for doing it like this. And they know what these reasons are. And so when I was pulling these slides together, this conversation happened on Twitter just a couple of days ago, which was just absolutely perfect. Because here's Peter, who is the lead developer for Ethereum Go-Ethereum with 1,200 commits. He's the #2 guy on our long tail graph. And he's saying that for me, the unit is the fork. Right? That's not without reason, right? He knows exactly what he's doing. And as you can see here, he says, you know, these are upgrades. These are EIPs. Why would anybody not want these? And I think that more conversations can be had around this tweet. I think that this might be a bit of a simplification or an exaggeration, because if we start to ask questions like, is a difficulty bomb an upgrade, and how do we manage that? Is just delaying that actually an upgrade? How about reduced block rewards? Is that an upgrade? And if so, why? So this is how Multi-Geth handles these configuration options instead. Instead of using fork-based configuration variables and interfaces, we've exploded it. We've unraveled these forks into their composite improvement protocols, specifications, so that we can speak articulately about exactly what we want our client to do. And this is good for Ethereum Classic, and it's also good for the multi in Multi-Geth. It's good for the many chains that we hope to be able to target. And I want to be fair about this analysis. I'm not, I want to present this as a pro and con and as something that is a balanced set of architectural trade-offs, because it is clearly working for Ethereum, Go-Ethereum. And for us, it is clearly working for Multi-Geth to do it in a different way. So what we can see with forks is that we get consistency. We get safety netted specification implementations. And that's a perfect example of what just happened this week with the EIP 2200 bug that was found. We get control. The developers have control because there's a little bit of obfuscation and there's a little bit of initiation that needs to happen before you can work with the code base. You get application level testing, but what you don't get are an extensible set of business use cases. You don't get an extensible set of articulatable test cases, and you have gated maintenance changeability. Whereas with features, we find that we get configurability. We have specification implementations that are really true to spec. And we can prove that through application and feature level testing, which is exactly how this bug was found. We find that we get accessibility because for somebody reading this code, they can actually go directly from a configuration value to a specification by name, and that should be one-to-one. We find that we can support generalized business use cases, have better, more descriptive, at least, testing. And so to finish off with this comparison, and back to our wayfaring and navigation guides example and the New York City train system maybe, I think it's fair to think about Ethereum, Go-Ethereum as the case on the left here, as exactly how to get from point A to point B. If you want to fly from here to wherever Ethereum is today, you can use that client and get there. And in doing that, it's an application of the protocol. It is one way in which this protocol can be applied to one network or a handful of networks if we include the test networks. Whereas with Multi-Geth, we're hoping to build something near to a protocol implementation, which is to say something that can become a tool for using the protocol. If you have questions on that, I'll be around. I'll be wandering around. Would love to talk to you more about that. But for a matter of time, we're going to move on to some other things. The next two facets, which I want to handle in tandem, because they really are two different aspects of the developer lifecycle for somebody who's going to be what I'm going to call a protocol consumer around the Ethereum-based blockchains. So I'm going to start with the EVM LVM project. But before I do, I want to sort of frame why I'm talking about these in tandem. They're in tandem because when you're writing your contract right now, the primary way that you're going to do that more often than not is going to be with Solidity, which is going to present a learning curve, and it has its own set of limitations. It's relatively young. And it comes back to language. This will probably be a new language for you if you're coming to the network and haven't been initiated. And also, being its own unique language, it has a distinct set of tools. And so what we're hoping to do is to be able to explode the number of languages that you can use on the front end in contract development and compilation, and then match that suite of accessibility experiences as far as languages go on the other side when you're finally consuming those contracts from the network. And so I'm running short on time and battery. So the LVM, just to touch on this, And I really am sorry to have to rush through this because it really deserves a talk of its own. But the EVM is essentially Ethereum's operating system. And an LLVM is a very mature 20-year-old project that has massive industry adoption, massive tooling support, great debugging, code validator tools, static analysis tools, and again, industrial adoption, as well as a diversity of front ends that can be used. And so what the EVM LLVM project is doing is bringing the EVM as a target to LLVM. And you can see that here. He's saying howdy. And I wish I could talk to you more. In fact, better, I wish Alan could be up here talking to you more about that. Maybe he will be next year. But we're thrilled about this. Alpha is available, and you can visit that website to learn more. There's documentation there. And we'd love for you to get involved with that project. Power! Thank you. All right. Nothing works without electricity, especially not presentations or blockchains. All right, so the natural complement to this front end is then going to be the consuming end. One of the fundamental pieces and core pieces that has had reverberating impact through our tooling team and through the application facing side of our projects has been OpenRPC. And I want to make it clear straight up that this is way bigger than blockchain. It has massive impacts across blockchain because this is the lingua franca for protocol providers, not just Ethereum Classic and Ethereum and the many different protocol providers that are implemented under that space, but also for Bitcoin, Ripple. You can read the list. It's bigger than blockchain, and that's one of the things that's really exciting about it, is that it is really generic. And with this generic document pattern built now, this has been applied. We've applied this and are hoping to collaborate and build to get feedback and really push this into space as a standard specification that can be the sort of the common denominator between protocol provider APIs for application consumers using the standard interface that's available. And so you can see here that not only are we getting so here's the point I want to make about this, is back to the point about readability, is that not only is readability good for humans, which it is, and it's critical, but it's also good for humans who are working with machines. Because if you can present data in a way that is structured and predictable and documented, humans can write tools that can consume those documents as well. And that's a massive lever. And that's exactly what OpenRPC is doing, is becoming that lever. And I would invite you to this website. You can explore, you can see how dynamic and informative these tools that come from this lever can be. And 2 minutes, all right. And so I know that this is an example probably like the closer to an advertisement than an actual guide, and that's because it is. We have so many projects that I don't have time to talk about. But there's been, and suffices to say, there's been massive amounts of work that we've been doing to support the tooling and specification around OpenRPC and its application in the Ethereum space. So I have 2 quick little case studies that I want to do that are compositions, very, very pure compositions that come from these tools. The first is Expedition, which is becoming a very popular explorer because it's very lightweight. It allows you to run and query blockchains and explore your blockchains, whether they're canonical and you're finding the endpoints upstream, or whether they're a testnet that you're running locally. And finally, we'll see if this guy will. Video cannot be loaded. Signatory, that was going to be an awesome video that walks through what you'll find if you visit this website. It's right there. And it is an example of how we're able to reuse these tools to not only build tools, but then build the documentation that supports them. Signatory, by the way, is an offline Ethereum message and transaction signer. that we've put together. So we would encourage you to read and build more. We'll be here. Our booth is upstairs. Any of us would love to talk to you about this and answer questions. I'm afraid I'll be pulled by the wrist off stage if I ask for questions. But thank you very much. My name is Isaac.